Bob has a question. Welcome back, everyone, to the FAA 2008 Sun and Fun. Our next program is going to be conducted by a FAASTeam program manager, an FAA safety program manager, a colleague of mine. Mark Laughridge comes from the Orlando office. He's got a background in aviation maintenance. But the thing that will unite us all is his passion for aviation and his passion for fun, along with safe aviation. Please welcome Mark Laughridge. Have a good time.
Thank you, Kathleen. It's great to be here. Sun and Fun is really going to have a great show this year. What I want to talk to you today about is failure to follow procedures. And this covers not only aircraft maintenance, but also pilots. Procedures are something we usually do something to do with them every day. So at any rate, without further ado, a little bit of introduction to failure to follow procedures. We're going to go over some causal factors, then also some maintenance errors. A bit of an overview. Like Kathleen told you, I'm with the FAA safety team. We're going to go over some regulations involving some of the maintenance procedures, an accident scenario, maintenance error findings, the aviation or safety net, safety motivation, and some safety tools. Objective, to provide awareness of the risk associated with failure to follow procedures, prevention of contributing or causal factors to help reduce maintenance errors. And again, this is brought to you by the FAA safety team. Mental limits. Here we've got a bolt with numerous nuts on it, and obviously you have to take one off at a time. Only one way to take it apart, but there's many ways to put it back together. And your task here will be to remove these nuts from the bolt and reassemble them back in alphabetical order. Easy task, right? Of course, there's only one way to disassemble them, but over 40,000 ways to reassemble them. Let's get started. Before we do, let's read out of the good book of regulations. 4313, performance rules. A says that each person performing maintenance, alterations, preventative maintenance on an aircraft, engine, propeller, or appliance shall use the methods, techniques, and practices prescribed by the current manufacturer's maintenance manual and instructions for continued airworthiness prepared by its manufacturer, or other methods, techniques, and practices acceptable to the administrator. Further, he shall use the tools, equipment, and test apparatus necessary to assure the completion of the work in accordance with accepted industry practices. If special equipment or test apparatus is recommended by the manufacturer involved, he must use that equipment or apparatus. And what I want to emphasize here is anywhere where you see shall or must, these are requirements. There's no getting around that. It goes on to say in 4313B, each person maintaining an aircraft shall do that work in such a manner and use materials of such a quality that the condition of the aircraft airframe, aircraft engine, propeller, or appliance worked on will be at least equal to its originally or properly altered condition. Now here, where it says at least equal to, many times, and many of you may have heard the term, it's better than it was to begin with, better than original. Well, if it was better than original, then it's no longer meets that original. It's now been altered. And to alter anything with an aircraft, you've got to have approval for that alteration. So what we emphasize, and this is again, the minimum standard, is that it is at least equal to its original or properly altered condition. Further in 4315, the performance rules for annual inspections and 100 hours is that each person performing an annual or 100-hour inspection, again, shall use a checklist. That includes the scope and detail of Part 43, Appendix D. Before approving a reciprocating engine-powered aircraft for return to service after an annual or 100-hour, each person shall run the engines to determine the satisfactory performance of the power output in either static or idle RPM. And again, this information can be found in the manufacturer's maintenance manuals, also in the type certificate data sheet. That's a very important document that many people feel like they don't have access to, but actually through FAA.gov, it's available to anyone online. Also, you need to check the magnetos, the fuel and oil pressure, cylinder and oil temperature. These are all important, and again, all this information is available at on the type certificate data sheet or in the current manufacturer's manuals. For approving a turbine engine aircraft for return to service after an annual or 100-hour, each person, again, shall run the engines to check the satisfactory performance in accordance with manufacturer's recommendations. And many times here, the only way you can accurately determine whether or not that the engine meets this standard is through these manuals, because there are various charts and graphs needed to determine this for the day's condition, temperature, etc. So, we've discussed 4313, that the industry-approved tools are needed and when we have to use them, the methods, techniques, and practices, and the performance standards. Additional procedures may include service bulletins, service instructions, airworthiness directives, which usually tie into the previous two mentioned there. Again, the type certificate data sheet, very important document. Also, supplemental type certificates. These are where the aircraft has been altered, but not a major enough alteration to require a new type certificate, but still major enough to where it, for instance, could not be field approved by an FAA inspector. Instructions for continued airworthiness, the advisory circulars, 4313-1B, or inspection procedures for Appendix D of 43. We're also going to cover some aircraft accident statistics to show you why that failure to follow procedures can lead to a very bad day. Let's look at some of these statistics from the national statistics by the NTSB, accidents they've investigated, and some causal factors. This deals with the significant accidents caused in 93 major airline accidents by Gabriel and Marks, and it was determined that 12% of maintenance and inspection deficiencies were attributed to accidents. The failure to follow maintenance procedures can result in death, injury, occupational injuries in persons, or damage or loss to equipment, property, or damage to the environment even. Well, let's look back from when aviation started to today's present time. In the early days in early 1900s, when the Wright brothers got all this started, at that time, the human causes were few. We had very little control over the aircraft there, but the machine causes, because there again, we had no standards really at that time as to how aircraft were built. So at that time, the mechanical problems were many, the human causes were less so. But again, we've always got that element of human error. And human error is defined as the unintentional act of performing a task incorrectly, which can potentially degrade the system. And there are three types. Error of omission, which is not performing an act or behavior, just didn't do it. Error of commission, which means performing a different act or behavior, something that's out of the norm that you would normally do. Extraneous error, performing some additional action, change from the norm. For instance, I mentioned about back in 4313, the standard there for and I mentioned where a lot of people say, well, it's better than original. This would be an extraneous error. Now, this is a photograph from the late 1800s, somewhere in France, where this locomotive, something tells me the operator there probably failed to follow a particular procedure, which this was the end result. Human error. There are different levels of consequences of human error. There's little to no effect. You've got physical damage to equipment. And then we've got personal injury and ultimately a catastrophic event. Now this is an example of a U.S. Air Force aircraft. This was a KC-135. It was being pressurized at ground level. The outflow valves, which were used to regulate the pressure of the aircraft, were capped off during a 5-year overhaul and had never been opened back up. The post-investigation revealed that the civilian depot technician had always done it that way, using a homemade gauge and no procedures. The technician's gauge didn't even have a max peg for the needle, so it was no surprise when he missed it when the needle went all the way around the gauge the first time. As the technician continued to pressurize the aircraft, and as the needle was on its second trip around the gauge, the aircraft basically went boom. The rear hatch was blown over 70 yards away behind a blast fence. In this incident, even though it seems funny, they're never really funny. And it's further regrettable when you consider that this mistake caused us, the taxpayers, a lot of money. Fortunately, no one was reported as being injured. Now, this is a good lessons learned for making sure that we have trained people who have the right tools and who are following detailed procedures. And it should serve as a reminder that just because you've always done it that way does not make it the right way. Let's take a picture of this aircraft. Here you see that that's going to take quite a bit of work to get that back in shape, which obviously would never happen at this point. And if you'll notice the hatch between the two blast fences, that's that hatch that was blown off the aircraft. Failure to follow procedures are a result of human errors related to, 1, a lack of knowledge, lack of current technical data, lack of experience, lack of proper tools or equipment, also a lack of training, which can then tie back into the lack of knowledge, lack of proper preparation, resources, and failure to take safety precautions. Also, failure to research and follow federal aviation regulations. This is an accident we're going to discuss, Flight 5481. This accident happened on January 8th of 2003. And in this, you'll see where there were numerous procedures that were not followed. It was a Beech 1900 with 19 aircraft, or 19 passengers, 2 crew. They lost pitch control on takeoff and crashed, killing all aboard. Probable cause was the loss of pitch control during takeoff, resulting in incorrectly rigging of the elevator control system, compounded by the aircraft's aft center of gravity. Contributing was the operator's lack of oversight of the work being performed at a maintenance station, maintenance procedures, documentation, and weight and balance. The mechanic who adjusted the flight controls on the Beech 1900 turboprop was doing the job on this type of aircraft for the first time, according to sources. He expected the inspection by his supervisor, and whether that inspection occurred was never really determined. The mechanic was told to do the job, according to the sources, that his inspector or supervisor told him to follow the steps and that he would watch him. But the guy was busy, his supervisor, and this did not happen. He was managing the rest of the operation there at the hangar. I'm sure it was quite a busy atmosphere. Now, at some of the bigger maintenance bases, including some of the third-party shops, there's typically more support for a mechanic, including inspectors, a more supervisor, and experienced co-workers. If you'll notice there on the left, there's a detailed 6 inspection work card talking about the aft fuselage empennage, and it includes there the nonspecific references and inadequate instructions that were available to this mechanic. What he followed was what he was given. What he didn't know was that this aircraft on the right here, that because it had a specific flight recorder installed in the aircraft, flight data recorder, it required different procedures. But in the task card he was given, there was no reference to those procedures. So he had no idea that there were additional procedures involved. Now the NTSB findings found that there was failure to follow procedures by the company, the manufacturer. There was failure to document actions, failure to communicate in the turnover process, in supervisory oversight, regulatory oversight, and that there was generally a lack of safety culture. Their recommendations for Flight 5481 was that for the manufacturer of Part 21 aircraft, they identify appropriate procedures for complete functional checks of each critical flight system, determine which maintenance procedure should be followed by such functional checks, and that for manufacturers and 121 air carriers to modify existing maintenance manuals to contain procedures at the end of maintenance for a complete functional check of each flight control system. Part 121 air carriers implement a program in which air carriers and aircraft manufacturers review all work card, maintenance manual instructions for critical flight systems, ensure the accuracy and usability of these systems to the level of training its mechanics. Preventative measures, by employing the performance standards set forth in the regulatory requirements, the manufacturers and operators' procedures. Some of the safety nets that we've got are performing the task to the best of your ability, perform it to the task where it's equal to its original condition, perform the task in accordance with appropriate data. Also perform the task using methods, techniques, practices acceptable to industry and the administrator. Also perform the task without pressure, stress, or distractions. Have your work re-inspected by someone prior to returning it to service. Make sure you've done the properly recorded entries for the work performed in the aircraft maintenance records, and perform operational checks, again, in accordance with the manufacturer's or air carrier's approved procedures. The motivation. Your motivational considerations to do the job to the best of your ability are to lower your risk and your liability. Obviously, this day and age, liability has a large effect on pretty much everything we do. Take pride in your work. This also reflects your character. And it's your responsibility as a professional. It's good for the company. It's good for the profit and losses. Anytime there's a loss, that definitely affects the bottom line. It's also good for business in the public confidence. If there are an air carrier that has many incidents, the public's going to take note. The bottom line is the safe thing to do. Here we have a safety maintenance tool. And again, this is, whereas most of this presentation deals with maintenance, again, this carries over into the pilot arena because again, pilots in general aviation aircraft are responsible for the airworthiness of their aircraft. In this maintenance tool, safety tool, we have a before task. On the back side of the safety tool, there's after the task. And I won't go over each one of these, but I encourage you to go to your local FAA office, contact a FAA safety program manager to get you a copy of this. This can be used in not only for maintenance, but also you can utilize this after you've received your aircraft from maintenance. And again, we in the FAA, we stand ready to join with you to guide you and assist you in every way possible. But the primary responsibility for aviation safety rests with you. Thank you. Thank you, Kathleen.
Mark's going to stay around to answer some of your questions. He gave you a whole lot of detailed information, and he gave you a whole lot of specifics. And in the bottom line, we're talking about safety is how you do it, day to day. And now we'll be switching up to Studio B and go forward with the rest of our program. See you back later. Come on forward.